So,
here's work to do it.
So here's what I want to do. We have started right angle trigonometry, right? So at first I'm just going to remind you really briefly, what that means. So if I had any right angle triangle, you can draw any one you want. Doesn't have to be the same as mine. Yes. If we had a right angle triangle, I'm going to pick this angle down here in the bottom right-hand corner, and I want to know about that angle. What symbol would I put in that corner if I want to know about that angle? An O with a line through it. What's an O with a line through it called? Theta. Good. So there's my theta. There's my angle of interest. Well, we would know then that I could name the side. Theta! Give it a theme song. That was like, did anyone see Batman versus Superman? I thought it was kind of a joyless affair, and I love comic books. I love comic book movies, and yet like these DC movies are just like it's so dark and depressing. But they're not dark like the Christopher Nolan Batman movies were, where you felt like you were learning something about the human condition. They're just kind of badly made, I think. Anyway, I really didn't enjoy Batman vs Superman, except for the moment when Wonder Woman appears, and all of a sudden there was like this 80s speed metal guitar solo behind her, going like, I was like, that's great. I love the theme music. The best part of that movie was Wonder Woman's theme music. Anyway, I could now, which yeah, it's not a sign that it's a great movie if the best part is the guitar solo. How would I name these sides now that I have this here? Yes, sir.
Opposite.
Which one? You're totally right. Left, bottom, right. Like up here, over here, down here. Over here? Very good. How'd you know that? You're totally right. It's across from? Yeah, it's across from the theta. That makes it the opposite. Good. What other side could we label? Whoa, yeah, you're totally right. What side?
It's across from the right.
So like this. So is that it? Great. I'm so mad. There we go. Okay, let's try again. Very good. The adjacent, which is the other side. It's the side that touches the theta that isn't the hypotenuse, but it's just the other side. So there we go. We know that. And of course, we can then, from this, name our three trig ratios. What are the three trig ratios again? SOHCAHTOA. Oh, good. Very good. I was just about to ask you that. So we remember them using this little nonsense word, SOHCAHTOA. What do those stand for? The S tells me about what ratio? What do we call it? First one. Sine. So we say the sine of theta, and we would calculate that by looking at what over what?
The opposite and hypotenuse.
Opposite over the hypotenuse. Good. What's my next trig ratio, and how do I find it? Cosine. Very good. Yep, very good. And the cosine of theta is found how? Good. And what do I do with them? Very good. And my third trigonometric ratio is sine, cosine, and tangent. Very good. And how do I find the tangent of theta? Good. The opposite divided by the adjacent. So those are my three trig ratios. Now, the other thing I could, of course, do, so those are three ways to measure that angle theta. What's the fourth way I could look at angle theta and see how big it is?
Measure it.
Measure it using a protractor. I can just put a protractor up to it, and I can see how many degrees it is. So there's four ways we know to measure an angle. Does that make sense? What I want you to know is that just like any angle that's 30 degrees is always going to look the same. Does that make sense? If I say make a 30-degree angle, how many ways can you do that? Just one. It's always going to look the same, right? That's just as true. 30 is the same thing as its cosine. Whatever the cosine of a 30-degree angle is, any angle with that cosine will be 30, and any angle that's 30 will always have that cosine, no matter how big or small you make the triangle. Does that make sense? Those are all ways of saying the same things. So I have given you on the next page, if you think this is a lot of numbers, I invite you to turn to page 2. Come on.
Oh my.
Yeah. Ready? I typed that in myself, kids. That's true. It's true. It's a true story. So, I gave you a little table like this. Now, listen, eventually I'm going to teach you how to use your calculator for this. But first, we're going to learn how to look it up in a table. And I want to tell you why. It's not because I like torturing children, though I don't like any of you, so it brings me joy to be mean to you. But even if I did like you, which I don't, I would still give you this note. All right? Because seeing it this way is going to help you understand. So that later this week when put it down. Okay. Later this week, when I let you do what we're about to do on the calculator, you'll understand it. The calculator won't be a magic box that shoots an answer out at you. The calculator will be something that makes your life easier. And I want the calculator to make your life easier. But before we do that, just like if I handed a grade 3 student a calculator and said, I want you to use this to do adding, subtracting, multiplying, and dividing all the time, they would never learn to understand what adding, subtracting, multiplying, dividing really mean. So first we make them do it by hand. Then by the time we're in high school, we say, okay, now you understand it. Now it's okay to give the calculator to make your life a little easier. But you have to understand it first. So I always make students for the first week use the table because it's going to help you to understand. So here's what I want you to know. Let's just look at one line, one example. We're going to look at an angle of what? Just this one I'm looking at. An angle of 49 degrees will always have a sine of, 0.755. So if I tell you an angle is 49 degrees, you could take a protractor and draw that, right? But if I told you an angle had a sine of 0.755, that means that angle must be 49 degrees. Likewise, if I told you an angle had a cosine of 0.656, then that angle must be 49 degrees. And if I told you an angle had a tangent of 1.150, then that angle must be 49 degrees. Does that make sense? So this is going to come in useful later. But first, I want to just make sure you can look this up. I want you to tell me what the sine of 45 degrees is. And it didn't fit on this table, so you're going to have to flip to the next page and look up 45 degrees and tell me what its sine is.
0.70.
0.707? Good. So we can put that here. So 0.707. I want you to look up the next two. Cosine of 67, tangent of 36. Take a minute and do that.
Oh.
Yeah, I had to break it into two columns because it just didn't fit. By the way, it's not actually a hard table to read, is it?
No.
No.
You said you wanted the sine?
The cosine of 67 is the next one.
0.92.
Okay, write it down. And all three decimals, please. All three decimals.
Oh, that's not right there. Huh. I didn't know.
Oh, you jumped into that computer. right, so when we looked this up, the cosine of 67, what did we find? What did we find? Yes, ma'am.
0.391.
0.391. Good. That means any angle that's 67, if you made a right angle triangle, and it had a 67-degree angle in it, and you found its cosine, you'd get 0.291. Always, no matter how big the triangle, no matter how small the triangle, if the cosine of its angle is 67, or if its angle is 67, the cosine of that angle is going to be 0.391. What about tan of 36? What did that give us? Ma'am? 0.727. Good job. Now, I want to show you, too, that we can go the other way. What if I don't know the angle, but I know that it has a cosine of 0.423? How'd you do that?
I look for the cosine of 0.423.
Okay, so here's cosine. And if I go down 0.6, 0.5, 0.423, and what angle is that? That's okay. You found 25. That's just because you looked at the sine. That's okay. Listen, that's a great mistake to make. It's a great mistake to make because it shows you the thing you have to watch out for. But does everyone see this? I just looked down the cosine column until I found the cosine I'm looking for. And then I look at what the angle is. So what's the angle? Oh. This one is 65 degrees. Try the next two. And look at you. You're so good. And just be careful. Make sure if it's sine, you're looking in the sine column. If it's tan, make sure you're looking in the tan column. If it's cos, make sure you're looking in the cos column. Can I see? 33. That's very sing-songy of me. Yeah, I like that. Well done. And 64. Yeah, well done. Feel the same? Yeah. Great. Good job, guys. Allow me. Oh, too slow. Fantastic. Good job. I got that Sky Zone moved in upstairs. Has everyone been to Sky Zone? So my kids dragged me to Sky Zone, and it was like the most enjoyable afternoon I've ever had, I think. It was just wonderful. That is a good time.
My family's friends, like their family basically.
Yeah.
We're going to Sky Zone, and they asked my mom, like, hey, and we're like, Sky Zone. My mom's like, no, I don't know. So they went to Sky Zone. They were gonna invite me, and they went to Sky Zone. And my mom's like, so I didn't know if you like Sky Zone. I'm like, yes, I love Sky Zone. Why? Like, I've never been there. I really want to go. She's like,
I would have
shit.
scrapped.
I'll see if I get. That's so disappointing. I'll have to see if I can find the videos. A teacher I used to work with, her son is a competitive trampoliner. It is. So this kid is 11, and he does double trampoline routines. So there's like a small little, just the little like 3-foot trampolines, 2 of them, and he like jumps onto one and like all these flips, lands on the other one, like goes between them. We'll land like with 1 foot on each of them and go. It's friggin' crazy. And I just think like this kid's gonna snap his neck. I can't. It makes me uncomfortable to watch, but it's so amazing. That's probably good advice.
And I fell, and my back went like completely bended in between the fence and the trampoline because the trampoline was frozen to the ground. So and I completely folded.
Oh gosh.
I went to the trampoline park in Mississauga.
Nice. Is it a big one?
Yeah.
That's great.
That's when I had long hair. Some guy at the worker was calling me Rapunzel.
I like it. You do still have longer. Was it longer than this?
Yeah.
Wow. That's awesome.
My skin is good.
Oh, I'm sorry. All right. What angle gives us a sine of 0.545? What did we find? 33 degrees. Good. And what angle gives us a tangent of 2.050? 64? Good job. Okay, lesson's almost done. So we know how to look these up. Now, can we use this to actually do something productive? Well, let's look at this triangle. Now, this triangle you've seen before, you may not realize it, because I just copied and pasted it from our first note where we looked at finding sine, cosine, tan. So if this is theta, what will this side over here be? Opposite, adjacent, or hypotenuse?
Opposite.
Very good. What will this side up here be? Hypotenuse. And what will this side down here be? Very good. Okay. Now, it doesn't matter which one we pick, but we're going to do all three. Normally, you wouldn't do all three because it'd be a huge waste of time. But to prove a point, let us find the sine of this angle theta. How do we find sine again? Very good. Opposite over hypotenuse, which in this case means what over what? Cass, do you mind giving everyone a calculator? Be my girl. Opposite over hypotenuse, so in this case, what over what?
What is it? 2 over 18.
Very good. Okay, do that on your calculator, see what we get. That's frustrating.
It comes off like.
Okay, what do we get? 3 decimal places when we do that. What do we get? 0.233? Okay, perfect. Now, here's what I want you to do. I want you to go look up in the table what theta must be in degrees then. If the sine of theta is 0.233, what's theta? By the way, it may not work perfectly. You've got to pick the closest one. Eventually, when you do it with your calculator, it'll tell you the decimal, but we don't have decimals, so you've got to pick the closest theta to a sine of 0.233.
Oh, wait.
Yeah, I agree with that. Does everyone see that?
The other one.
Sine of 225 is basically 13 degrees. So if I know the theta, sorry, I interrupted you. And now you're eating, so I'm going to keep talking. If we know the sine is 0.233, we can go to our table and we can see how many degrees that must be. Which is good because if I have to build something and somebody tells me, build it with a sine of 0.233,
Oh, 13 degrees.
that's tricky. But if I can go into my thing and say, oh, that's 13 degrees, now I grab my trusty protractor, I set up my straight edge, and I make my line. Boom, done. Just like that. Okay. Now, if we did our math right, these should all work out to about 13 degrees, but let's try all 3 ratios. What's the next ratio? Cosine. How do I find cosine? That's enormous. I'm going to run out of room.
Is it like opposite over adjacent?
This one is adjacent over hypotenuse, so toa. That's okay. Remember our little nonsense word, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then the one you want, opposite over adjacent is tangent. Good. What is the adjacent in this case? 17.5. And how big is the hypotenuse again? 18. Good. Do that in your calculator. What do we get? 0.8 something, 0.9 something? What do we get? What do we get? 0. I got to be honest, guys. I don't know my 17.5 times table very well. Okay, I guess I do. 35, 52.5. 65, I don't know. Okay, could somebody just give me the answer, 17.5 divided by 18, while I keep embarrassing myself up here? That was great. Could one of you... Megan, could you tell me? 9.72 or 0.972? Okay, good. I like that. So, can we look that angle up? See what we get. Go back to the table. A cosine of 0.972. You got to pick the closest one. Well, it's obviously between those two, right?
No, we'll say it's 14.
So it's 13 or 14 degrees, right? It's kind of right in the middle. So, okay. In other words, it agreed with our first one, didn't it? All right, and obviously if we've done the sine of theta, we've done the cos of theta, the third thing I could do is the tangent of theta. So let's take a look at that. Tangent of theta is what over what? Anyone? Bueller? Sorry, yeah, it's over A. What's on top? Oh, good. Thank you. Very good. What is the opposite in this case? 4.2. And what's the adjacent? Very good. And if we do that in our calculator, what do we get? What do we get? 0.24 third decimal? Oh, it's perfect. Okay, so 0.240. And let's look that up as well. Look up a tangent of 0.24. And it's closer to 14, I guess, right? So that will give us 14 degrees.
So what? Want to do the other two?
Yeah, now listen, these don't agree perfectly because our table just goes to the nearest degree. So this angle is obviously somewhere between 13 and 14 degrees. Does that make sense? That's as close as we can get with the table I've given you. Don't worry, by the end of the week, you'll be using your calculator. It'll tell you to 15 decimal, well, no, it'll tell you to 7 decimal places, but still, it'll tell you to 7 decimal places what the angle is. But for now, we're going to find it to the nearest degree. So I would like you to do the same thing for the next 2 triangles, and then you can carry on with Friday's work. I've got to quickly run pick something up off the photocopier, and I will be right back. Sorry? Once these are done. Well, no, yeah, you can go to the tips. That's fine. Yes, you have your assignment for Friday. I think you do, unless you gave it to me. So make sure you have it, because once you're done this, I want you to do that, and I want you to make sure I changed question 3. I think I changed Lewis and Michaels. I want to be 100% sure.
Oh, yeah.
Did I? I penciled in the number there? Great.
I go to the washer.
Yes. Okay, so I want these 2 triangles, same thing we did here. Figure out how many degrees that thing is. No, I like it. I think it's beautiful. Let's stay. On the other hand, the where's my cookies? That's going to be erased. That is less beautiful. But the art is awful. That stays.
I kind of laughed at the fact my mom was like, "Oh, you could do better in math." I'm like,
You're doing great. Yep. Oh, which reminds me, I have your test. I want to give you your test so you can put up on your wall. How you doing, gentlemen?
That's good.
Are you all done? Yeah. Wow, that's quick. It's something when I hit the lights. It's kind of gloomy.
How come there's only 3 people in the class?
They've scattered to the winds. Okay.
"What is it? I don't want to like."
Yeah, they both wild. Okay, so Brody, sir, I'm going to give you, here is the first note from the unit, and I'm going to give you my, do you have headphones? By chance?
I have headphones for everything, but I'm not gonna let him.
Okay, I'm just going to have you watch that last one. You can fill that one up, and then I'll give you the assignment that came after it. And then you can, after that, further watch today's. And I'll do that. So, let us, because tomorrow we'll pick up here.